Today class about limit of several variable function. So we are interesting to find some expression of two variable as we are taking example xy tending to point zero zero, and the function is xy square upon x square plus y raised to the power 4, and we have to check that limit of this expression is either exist or not. So we have many criteria to check limit of this function exist. One of them is, or few of them are, sequential criteria. If we are choosing any sequence which are tending to this limiting point, then by sequential criteria limit of xn, limit of fxn will tending to limit of same. It is a sequential criteria of convergence. Second one is using polar coordinate system, and third one is by path method. Whenever you have to discard options, so most of the case we try polar coordinates and by path coordinates, because of we can't prove limit of a function either in one variable or several variable exist using this concept polar coordinates or by path coordinates. In one variable it might be helpful, but in several variables we can't prove limit by this method, because of we cannot consider all path which are tending to the point limiting point. We cannot consider and we cannot find limiting values. So we prove limit of several variable function using epsilon delta definition, but existence we can check by polar coordinates or by path technique. So put x equal to my square. Using this substitution what we have, limit xy tending to 0 0. If we are getting same limit using all paths, then we say limit is exist, otherwise not, either in polar coordinates or in a Cartesian system. So it will be my square upon my square into y square divided by m square y raised to the power 4 plus y raised to the power 4. Take y raised to the power 4 as a common. What we have, limit xy tending to point zero zero, and expression we which are free from y, or you can say this expression limit is only you need to check at 0. So m upon 1 plus m raised to the power 4, sorry, square, and for different values of m we will get a different limit. So limit doesn't exist. But using polar coordinate system, if suppose this is a rectangular system or Cartesian system, so if anyhow we are approaching point 0 0 or any point, so one by one we are checking paths. So take theta as a fix, so you can consider as pi by 4 or pi by 2. So theta fix, make theta fix, and r tends to 0, then it this polar coordinate system will help you to reaching 0 0 with a fixed path, and you can say only a straight line as r is reducing to 0. So using this concept we use substitution as x equal to r cos theta and y equal to r sin theta. Using this substitution, what we have, limit r tending to 0, r cos theta into r square sin square theta, r square sin square theta upon r raised to the power 2 cos square theta plus r raised to the power 4 sin raised to the power 4 theta. For taking r square as a common from numerator and denominator, and it will cancel out. So left expression we have r tending to 0, r cos theta into sin theta divided by cos square theta plus r square sin raised to the power 4 theta. In numerator, if we put r tending to 0, numerator will tends to 0, but denominator will depends on cos square theta. So we have different cases. If cos square theta is 0, then we will get tending to 0 in numerator, and in numerator tending to 0 in numerator and denominator, because of cos square theta is 0. So tending to 0 upon 0, we have 0 by 0 form when cos square theta, not 0 by 0 form, because of cos square equal to 0. This implies that cos theta equal to 0. So it will it will be in numerator tending to 0 into 0, exactly 0. So here this is not exactly 0, because of r is somehow positive value and this is tending to 0. So in numerator part we will get 0 upon, because this is exactly 0, and this part is tending to 0, as you are getting, because of in denominator part r is tending to 0. So exactly 0 upon tending to 0, we get 0 finally. So from this, when cos square theta is equal to 0, if cos square theta is not equal to 0, so in numerator part we are getting tending to 0 upon some non-zero value. So from here this is 0. So whatever you choose r and theta, because expression is never changing. So limit is polar coordinate saying, polar coordinate system is saying limit may be exist, may or may not be, but by path concept we already find that a limit doesn't exist. So we are reaching to points in using polar coordinates. We can't say limit, but you have to focus on this point, why in polar coordinates we are not sure, because of we are only consider as this is origin, and you are approaching origin from only straight line which are passing through 0 0. So and in path concept we can choose any path, either in polar coordinate system or in other way, but in Cartesian system you can choose, as we took x equal to my square, so you can choose x equal to 2y square or x equal to 4y square. You have different values of m, So path may be different, but limit is also different. So by path concept we can say limit doesn't exist, and using polar coordinates, it seems as limit exists but not, because of we only consider straight lines which are passing through 0 0, not curves curve path. So limit of this expression doesn't exist.